Hello students, welcome back to the Geographical Investigation series, Data Gathering Methods for Coastal GI. In this video, we'll be going through how to actually do sediment analysis. Alright, with regards to sediment analysis, we will be going through these three questions. When do I use this method? How can I carry it out? As well as what do I need to consider when carrying out this method? So firstly, when do I use this method? Usually, sediments which make up the beach are not of uniform size. We have different sizes of sediments that make up the beach. Sediment analysis is done to determine the sediment makeup and distribution of different sediments across the beach profile. Basically, we do sediment analysis to actually determine where are certain sediments found, how does the composition of sediment differ between, let's say, the foreshore and the near shore, and then we want to come up with certain conclusions that can actually explain why this is as such. So there may be a reason why certain size sediments are found where they are. So what do you think are the possible reasons? This is something for you to think about. It can perhaps even be something that you explore in your geographical investigation. Alright, so questions that you should ask yourself when carrying out sediment analysis. Basically, which part of the beach are the larger size sediments found? Which part of the beach are the smaller size sediments found? And why is this so? So you want to identify kind of like a pattern of where these sediments are found along the beach or along the line of transect. So now we'll be going through the question of how can I carry it out. So the main goal of sediment analysis is to identify and classify sediments found on the beach. And this, as you can see here, I can have a sample of sediment found on the beach, and there are three things that you can actually do with regard to sediment analysis, which I'll explain shortly. So you can actually ask yourself, are the sediments in this sample rounded or angular? What does this tell me about erosion? So the roundedness of certain sediments can actually tell you quite a bit about the rate of erosion or the rate of, or the erosion related to transportation of the sediments along the coast. And another thing that you can question yourself is, what proportion of this sediment sample is made up of sediments smaller than 0.05 mm? So over here we have two different ways for us to analyze the sediment. So on the left, we're actually analyzing in terms of roundedness or roundness, whereas on the right, we are actually analyzing the sediment based on their size. Alright, so sediment analysis involves the following. Basically, you can identify the sediment type, you can measure the diameter of sediments, and this is usually applicable for larger sediments, and then you can determine the roundness of sediments. So these are the three things that usually make up sediment analysis, and I will explain these different parts shortly. Alright, so we will be going through how to conduct each of the following, so don't worry. You can actually rewind or rewatch certain parts of the video that in order to make sure you understand. So just like all the other videos before this, firstly, I'll go through what you need in order to carry out sediment analysis. Number one, you need a spade or something to actually scoop up the sand samples. Number two, you need a measuring tape in order to measure distances. And thirdly, you need a set of sieves. So the sieves are, as you can see here, the sieves are, the holes in the sieves are actually of different sizes. And this is, the purpose behind this is actually to sort out the sediments based on their different sizes, to analyze the proportion of sediments of different sizes that are found along the line of transect on the beach that you have identified. So similar to the previous method, step one, identify a line of transect. The line of transect is basically the line that runs perpendicular to the water. It's basically a straight line. And then step two, you want to conduct sampling along the line of transect based on the sampling method that you have chosen. Okay, so remember, we have went through stratified sampling, we have went through systematic sampling. However, there's one more sampling method which I will explain shortly. What I need you to know here is that let's say you have identified in terms of systematic sampling. You have identified an interval of 2 meters of where you're going to collect the sand. So a good amount of sand to actually collect at each point will be around 100 grams of sediment, and you will analyze this sediment when you return to the lab, or even where at the coast itself. Alright, so now we will be going through the different sampling methods, and I'll make it visual so that you can imagine how this actually happens. Okay, so the sampling method that we have not talked about up till now is actually random sampling. So random sampling actually works is that it works in a fashion where you collect samples based on a random location or distance along the line of transact. So for example, you can roll a dice, you can use a random number generator, and then you follow that number. So that determines the interval between the 2 points which you collect the sediments. So the red dot actually denotes where you collect the sample. So for example, let's say first I roll the dice and then I roll the 2. So that's 2 meters I collect. And then I take the dice again, I roll again, and then I get 6. So I will collect 6 meters after my last collection point. So the reason why we do random sampling is because we want to overcome the problem of me subjectively selecting a spot to collect. So by doing it randomly, it eliminates bias. So when we eliminate bias, our data becomes more accurate or more fair in a sense, and fair data is most of the time considered more accurate as compared to biased data. Alright, so this is random sampling. Okay, up next we have systematic sampling. You guys have been introduced to systematic sampling. It is basically the interval between two locations are regular or consistent. So for example, if I select my systematic sampling interval to be 2 meters, so every 2 meters I will go on collecting this 100 grams of sediment, and this continues until I, for example, cover the whole line of transact that I've identified. So we have went through random sampling, which is based on random number generated, and then systematic sampling, which is regular interval. So the next one that we'll be looking at is stratified sampling. Okay, so for stratified sampling, we have a different diagram because remember, for stratified sampling in the previous method, how we actually decided on where to collect samples is based on when the slope changes. So basically, let me just read out to you here. When you do stratified sampling, you collect samples across the transact at places with special characteristics. So in this case, the special characteristics is when the slope actually changes. So you see at B, the slope starts changing. At C, the slope starts changing. At D, the slope starts changing. At E, the slope starts changing, so on and so forth. So you see here the distance between the places where you collect the sample is not regular, but rather it is also not random, but rather it is determined by a special characteristic, which is when the slope changes. So you see 5 meters, 3 meters, 6 meters, 8 meters. It's not regular, and it's also not random because when the slope changes, then I collect. So that's how you differentiate between stratified and random sampling, is because it is not random but determined by a particular factor, and the factor here is the change in slope. Okay, so we have went through random, stratified, and systematic sampling. So I hope you guys understood the different types of sampling methods. If you don't, just go through this part at your own convenience. Okay. Alright, so let's say I use systematic sampling. Let's say I determine 2 meters to be my interval where I collect. So I will conduct sampling along the line of transact based on the sampling method that I have chosen, and I'll collect, for example, 100 grams of sediment at each point. Following that, what I will do is, after collecting samples from each point, I will need to find out the makeup of the sample based on the size using a set of sieves. Okay, so as I've mentioned earlier, these sieves, the holes in the sieves are actually made up of different, they are different sized holes, right? And they allow different size sediments to go through. So for example, let's say you put all your sediments into this largest one. Some would actually remain in this largest sieve here, and then you will slowly actually see that as you shake it, the finer sediments will end up at the bottom sleeve here. So what you can actually do is then you have to calculate the proportion in terms of weight of how much of a particular size sediment you've collected in relation to the total amount of sediments that you have collected. So don't worry, that might sound a bit confusing, but I will explain to you shortly. So just to explain to you how sieves work, remember the sieve only allows particles smaller than the holes in it to pass. So it actually retains, or it blocks some particles from going through when the particle is bigger than the holes in the sieve itself. Okay, so as you can see in the set of sieves just now, you can actually stack it and then you can shake it together so that you can filter the sediments more easily. Okay, so what you will actually do is that because each sieve allows sediments of different diameters through, you will want to record the weight of sand collected from each point. And then you will sieve, and then you identify the percentage of sediments of a certain size in relation to the total sand collected at that point. So over here I have an example for you. So let's say I am interested in finding out how many 4 mm sediments did I collect in relation to the total that I collected from a particular point. So let's say I sieve, and then the 4 mm sediments are actually trapped in the 4 mm sieve, and the number comes up to only 2 grams of sediments were of 4 mm in size. Then what I do is that I put the observed weight, which is this 2 grams here, or the weight of the interested sediment, 2 grams, divided by the total weight. So I collected 100 grams, for example. So 2 grams over 100 grams, and it only makes up 0.2%. So I think I got my math wrong here. It should actually be 0.02%. So particles which are of 4 mm size only make up 0.02% of the total weight of sand collected at a particular point. So when you have gathered this data, you'll realize that as you go from different location to location across the line of transact, the makeup of the composition of sand would actually differ. And then you have to ask yourself, why is this so? So why are, for example, why are huge sediments only found near the foreshore, and you can't actually find them at the back shore? There must be a reason to it. So why? Try to think about this. Okay, so basically in identifying sediment types, you simply want to know the composition of sediments based on size. Okay, so this is identifying sediment types. You can then compare how this composition is different across the different samples gathered along the line of transact, and perhaps come up with a reason of why this happens. Also, while you're on site, you may be required to identify the sorting of sediments at each sampling site. Are these sediments well sorted? Are these sediments poorly sorted? So you have a picture here. Your teacher may actually give you a chart below to analyze the sorting of sediments, and you can actually use this to actually analyze the sediments that you have collected, whether they are very, very poorly sorted, moderately sorted, or very well sorted. This can actually tell you about the type of sediments that are found at that particular point across the line of transact. So as you compare across the line of transact, you may produce conclusions such as the further away from the shore, the more well sorted the sediments are. And you can actually use this data, use this information to prove or reject a hypothesis that you may have prepared before you came to the field. So this is also very useful data that you can actually use in order to prove or reject your hypothesis. Alright, now that we're done with identifying sediment types, let's move on to the other two other methods which make up sediment analysis, which is measuring the diameter of sediments and determining the roundness of sediments. So, for measuring the diameter of sediments, actually very, very simple. We don't use this method all the time, but we usually do it in fieldwork sites where the beach is made out of large sediments, such as at a pebble beach. So at a pebble beach, it would not make sense to actually use a sieve because all the sediments, which are pebbles, would be trapped in the larger sieve. All right. So what we do at when the sediments on a beach is actually very, very huge is that we will use this thing here. You actually use a quadrant to identify samples of different size. So you can actually, usually people use, they choose a sampling method, for example, random, stratified, or systematic on this quadrant to select a box to actually choose where they pick the samples. Okay, so since the sediments are very huge, we don't use the sieve. What we use is actually vernier calipers. Okay, so you guys know how to use vernier calipers, right? You guys have learned this in physics. So I would not belabor the point and go on about how to read a vernier caliper. So after you have made the recordings and finding of the measurements, you'll put it in your recording sheet. And basically, that is how you measure the diameter of sediments. Very, very simple. For identifying sediment type, you just have to use the sieve because the sieve is of a particular size, and that size tells you the size of the sediments that are captured. However, for larger sediments, you need to use a vernier caliper, and then you need to find out the size of the sediments manually. Alright, so lastly, for the last component of sediment analysis, which is determining the roundness of sediments, basically, we will use this if we are interested in finding the rate of erosion on a beach, because the roundness of sediments tell us about erosion. So let me just bring up this image for you. Basically, sediments are more angular when there is less abrasion. So it means that during the transportation process, meaning during the process in which sediments are transported by the medium, which is water, as the rocks are actually as the sediments are actually hitting against each other or hitting against the sea floor or the river bed, for example, the sediments become more smooth. So as the sediment becomes more rounded, this tells us that there is a lot of abrasion happening during the transportation process. Okay, and as we know, abrasion can actually also it's also a form of erosion. A way that in which things can be eroded is through abrasion. So this can also inform us about the process of erosion that's happening at a particular site. Okay, so as sediments are more rounded, it hints that there is greater abrasion between them. Particles that hit against each other leads to smoothing of the sediments. You can also use the power scale of roundness to identify the roundness of sediments that you've sampled. So basically, by eyeballing the sediments or using a magnifying glass, you can identify whether they are very angular, so on and so forth. And this can actually lead you to very logical conclusions about erosion happening at a particular location. So there, very simple. That's all there is to sediment analysis. Let's see some important considerations that we need to keep in mind when carrying out sediment analysis. So basically, we just have 3 things to understand with regards to the things that we need to consider. Firstly, when I'm collecting my samples at my different sampling locations, my sample size must be large enough to be representative. It means that I cannot simply collect 1 grain of sand and then say that, oh, all the sediments are smooth, for example, or all the sediments are of a particular size. That would be very, very unfair. That would be very, very inaccurate. And therefore, you want to make sure that you collect a healthy amount of sediments in order for you to analyze. Secondly, the more samples you collect, the higher the representativeness will be, provided that you did your sampling correctly. Remember, if you do your sampling anyhow, you'll get biased data. Biased data equals bad data. Bad data equals to useless data in a way. Alright, and lastly, use a quadrant when you're doing sediment analysis on the beach. You do not need to use vernier calipers to measure fine sand because that is very impossible to do, so don't waste your time doing this. The sieves will be enough. Alright, so congratulations geographers. Now you should know how to conduct sediment analysis, which is useful in studying the sediment distribution across a beach profile. Remember, the consideration we discussed as it will increase the accuracy of your study, Next up, we will look at the methods to gather data about wave characteristics, in particular wave frequency. And just to bring up the overview, basically we have covered these two methods. So I am looking forward to seeing you in the next video. So thank you for tuning in.